In the three examples we did before, all the absolute values were on the left side of the inequality and they were already isolated. Let's try a few examples of what happens when they are not isolated. So we're going to try and isolate the absolute value, again making sure that this step doesn't create a less than or equal than a negative number. So let's see. Here's my absolute value on the left side of that inequality. However, outside the absolute value, I have this -2 and I have this +9. That means that the absolute value is not isolated. I'm going to have to move those to the other side of the inequality. First, we move anything that is being added or subtracted. So I'm going to move this -9. And then I'm going to have -2, absolute value of 4x plus 1. The -9 and 9 will get eliminated, is greater than 3 minus 9, different signs, we subtract, keep the sign of the largest. All right, we check again. The absolute value is on the left side of the inequality, but I still have this -2 multiplying the absolute value. So the absolute value is not isolated until I get rid of this -2. So that means that we're going to divide both sides of this inequality by -2. From left to right, the -2 divided by -2 is going to get eliminated. That's 1 times the absolute value, or just the absolute value. On the right side, I have -6 divided by -2. Well, that's going to give me a +3. However, we have to be very careful here because we divided by a negative number and we are dealing with inequalities. When we divide by a negative number, remember we need to flip that inequality. All right, so then now we have isolated the absolute value. The absolute value is on the left side of that inequality and there isn't anything else outside of the absolute value. Perfect. Step 1 has been completed. We move on now to step 2, just like we did all the other examples before this one. We're going to create the equations to solve. So the equation I'm going to use to solve is the absolute value of 4x plus 1 is equal to 3. What does that mean again? It means that 4x plus 1 is 3 units away from 0. So 4x plus 1 could be at 3, or 4x plus 1 could be at -3. So let's start solving. First, we move anything that is being added or subtracted. So from left to right, I get 4x. This gets eliminated, and 3 minus 1 will be 2. We're not done. We need to divide both sides by that number. From left to right, 4 divided by 4 is 1x, or just x. And on the right side, I cannot divide 2 by 4 evenly, but I can most definitely simplify. I can simplify this by 2, giving me a half. So that's the value I'm going to have to go and mark in the number line. A half is 0.5, that is between 0 and 1, right in the middle. Here it is. I'm going to mark it as a half right here. Don't lose it. Let's solve the other equation. We begin by moving anything that is being added or subtracted. So -1 minus 1. From left to right, I get 4x. 1 minus 1 gets eliminated. And on the right side, -3 minus 1, same sign. We add and keep the sign. Don't forget, we still need to divide by that 4 that is multiplying x. So from left to right, 4 divided by 4 will be x. And on the right side, -4 divided by 4 will be -1. So that's the other value that we're going to mark on the number line. Okay, now after I created my two equations to solve them and I have marked those numbers in the number line, I have to shade according to the inequality. However, I have two different inequalities. I have the greater than or equal to from the original, and then I have the less than or equal to. And you might be asking, which of the two should you use? Well, look at the equation that we solved. Did we solve the original inequality, or did we solve when we had isolated? Because we used the one that had been isolated, that is the inequality that we're going to use to shade. Because it's less than or equal to, we're going to shade in. So that means I'm going to shade between these two numbers. And because it has that equal to, that means that I include the numbers. Once I know which values are shaded, we read from left to right, and this is being shaded from -1 to 1/2, and we are including the values. So this would be the result for example 12a. Let's try one more. Looking at 12b, I notice that the absolute value is on the left side of the inequality, but it's not alone. It's not isolated. It has this -4 and this -3. Now you might be asking, which of the two should you move first? Well, we move anything that is being added or subtracted first, but sometimes it might be confusing to see which one is actually the one doing the adding and subtracting and which one is doing the multiplication. Well, if you notice, this 3 seems to be attached to the absolute value of x. You see how there is no symbol, there's no pluses or minus between the 3 and the absolute value of x. That means that this 3 is multiplying, and this -4 is the one that is adding or subtracting. So that's the one that we move first. I move the -4 plus 4 plus 4 on both sides. From left to right, this gets eliminated, leaving me with that -3 absolute value of x. And on the right side, I have -16 plus 4, different signs. We subtract, keep the sign of the largest, so that's -12. We're not done. Remember that 3 was multiplying x, so I'm going to have to divide both sides by -3. From left to right, this gets eliminated, leaving me with the absolute value of x. And on the right side, -12 divided by -3 is +4. And we have to remember again, because we divided by a negative, we have to flip that inequality. And now I see that the absolute value has been isolated. We have to make sure that we keep track of this one here, because that's the one we're going to use to know in which direction we're going to shade. Okay, but before we move there, I have to solve the equations, right? So this one is the absolute value is greater than 4. That means I'm going to solve the equation the absolute value of x is equal to 4. That tells us that either x is located at 4 or x is located at -4, because 4 and -4 are 4 units away from 0. Okay, once we're here, I'm going to notice that there's nothing for me to solve because x is already being solved for. So these two are going to be the values that I'm going to mark in my number line, the 4 and the -4. Again, if we go back to check the inequality so that we know in what direction we're supposed to shade, remember it's not the original inequality here, because at this point, the absolute value is not isolated. It's not until we got here that we isolated the absolute value. Since it's greater than, we're going to shade out. So from 4, I'm going to shade towards positive infinity. And from -4, I'm shading towards -infinity. I go back and I notice that this one doesn't have the equal to, so I'm not including those values. So I place parentheses. We write our interval notation by reading the graph from left to right. So this is -infinity to -4, and then again from 4 to infinity. We're not including the values, and remember that infinity always takes a parenthesis. Because our solution is broken into pieces, we place the union. And this is the result for 12b. Let's try one more example before we finish this video. Okay, let's begin with 13a. We notice that the absolute value is on the left side of the inequality and is not isolated. It has this 12 and 4. We're going to remember that since this 4 is attached to the absolute value, this is multiplying. So then we're going to move the 12 first because that's the one that is being added or subtracted. And we do that by subtracting 12 from both sides. From left to right, the 12s get eliminated, leaving me with 4. The absolute value of 6x minus 1 is less than, well, 4 minus 12 will be negative 8. We are not done. We need to move that 4 since it's multiplying. I'm going to divide both sides of the inequality by 4. From left to right, 4 divided by 4 is 1 times the absolute value, or just that absolute value. And on the right side, negative 8 divided by 4 will be negative 2. And I'm going to notice here that I divided by a positive number, so then the inequality remains the same. At this step, we have to be very careful. Why is that? Because we finally arrive at an example that has a less than a negative number. Remember, the absolute value measures distance, so it can either be 0 or positive. That means it can never be less than or equal to a negative number. So in this case, this inequality has no solution. Let's try it again. We do B. I notice that the absolute value is on the left side of the inequality, but it has that minus 6 and that plus 5. So I'm going to move the plus 5 first by subtracting both sides. From left to right, I'm left with negative 6, the absolute value of x plus 7. The 5's get eliminated, and that's less than or equal to 12. Next, we are going to divide both sides by negative 6. From left to right, negative 6 divided by negative 6 is 1 times that absolute value, or just the absolute value of x plus 7. On the right side, 12 divided by negative 6 will be negative 2, but because we divided by a negative number, we're going to flip our inequality into greater than or equal to. The way that we're going to read this here, it's saying that the absolute value of x plus 7 is greater than or equal to negative 2. Or better said, that the absolute value is greater than a negative number. Remember, an absolute value measures distance. Its distance is either positive or 0, and a positive or 0 is always greater than a negative value, then this inequality is always going to be true. So our solution will be from negative infinity to positive infinity. Thank you so much for watching, and I'll see you in the next one.